Okay, so now we're going to do the lateral column. And what's the lateral column? It's the anterolateral system. Okay, it's also going to be known as the spinothalamic tract. Alright, so we have two different names for it. It does the same exact thing. But what is important about the lateral white column? So an important thing that we have to remember, it goes up and it goes down. We have ascending fibers and descending fibers. Ascending was for what? Only sensory. Descending is for what? Only motor. Now, in this video, we're going to talk about strictly ascending fibers. Okay, in another video I'm going to talk about the descending tracts. But in this one, we're only going to talk about the ascending tract. We know that there's a couple different tracts that run through the system. The two important ones I want to talk about, we're going to do the anterolateral. So it's the this is the whole tract. It's called the anterolateral tract. We know that. And it's going to get split into two main ones. What are the two main ones going to be? It's going to be the ventrolateral tract. And then the second one is going to be the lateral tract. Lateral tract. Okay, so that should make sense, right? Anterolateral. So there's going to be a ventral one, so for the front. And there's going to be a lateral one. It's literally in the name. Anterior, lateral, lateral. But I'm going to get into it in the rest of the video. Just wanted to give a little brief overview. Okay, so now to finish this whole entire tract or the system, the anterolateral system of the spinothalamic tract, I'm going to go over a couple more things real quick. So, what did we say? We said the nociceptors with the A delta and the C fibers travel along, and they make what? We make the lateral spinothalamic tract. And then we said the Merkel's discs, the peritracheal and the free nerve endings, alpha delta or A delta and C fibers again, travel down, make the what? Ventral spinothalamic tract. Got our two tracts. First one we're going to talk about, the lateral spinothalamic tract, right? The green and brown one. What happens? So the C fibers, the green ones of this tract, branch off, hit the reticular formation. Okay? What is the reticular formation? It's an area in the brain, right? Run through the brainstem. And what does it do? Well, this guy's going to send different fibers. So you see that I have the arrow traveling up. And he's going to send these fibers to the intralaminar nuclei. We're going to talk about that in a later video, but just something to say. And this is for conscious pain. What is conscious pain? Okay, well, if you break your ankle, right, and it's constantly throbbing, the reticular formation is going to be like, hey, you know you're still hurt. Like, you can't go run. Like, you're still hurt. Now, we have different systems in our body. So when you're sleeping or something, right, you're going to go to sleep. It's going to turn these fibers, and we're going to kind of not inhibit them, but turn them down a little bit, right? You're not going to be sleeping. You're going to be like, I have a broken ankle. Like, you know you have a broken ankle. So right over here, it's going to tone it down. But that's going to come from our lateral spinothalamic tract, specifically C fibers. Now, when these C fibers branch out, what are they called? They're called the spino-reticular fibers. These spino-reticular fibers is our first tract that we're going to talk about. And this is the right over here is going to be the spino-reticular tract. Okay, here we go. Here's the first one. I'm sorry. It's called, here's the first one. I did it out of order. Spinothalamic tract, spino-reticular tract. Boom. Okay, we do him. He shoots these fibers up. We're going to a different location. Now, what do you think it's called when these spino-reticular fibers that are coming from this, what tract? This lateral spinothalamic tract. When these fibers branch out into the reticular formation, what is this? This is our third order neuron. Wow. Finally, we hit all three orders of that tract. Okay. These C fibers also continue up and they go into the thalamus. Stimulate different things, different functions. We're going to get that in more detail in the thalamus video. But just remember, for now, it's where they're going to go. Now, if we continue up, C fibers and the A delta fibers from the lateral spinothalamic lateral spinothalamic tract are going to do what? Going to branch off again. Okay? Some of them are going to branch off, and they're going to go to the parabrachial fibers, and this is going to target the parabrachial nucleus. Okay? Now, other fibers are going to branch off, and they're going to target the spinotectal fiber. They're going to be spinotectal fibers, and what are they going to target? They're going to target the superior colliculus. Oh my God, there's so much stuff, right? Just keep it organized, keep it simple, you're fine. These two things, right, they're going to be known as the spinotectal tract. Okay, so we could cross off another one. Now we have the spinotectal tract. Where's he coming from? Lateral spinothalamic tract, coming up, right? Boom. C fibers, branching off, targeting parabrachial nucleus or supracolliculus. Okay, these fibers are going to join together. They're going to be known as the spinotectal tract. What happens when they target these two things? What neuron is this? Yes, sir. Third order neuron. Boom. Okay, another thing that we should kind of know, that I'm going to go into more detail again. If I went into more detail with all of this stuff, this would be like a 7-hour video. So the superior colliculus mainly targets, its main muscle is the lateral muscle of the eye, like the lateral retina muscle of the eye. That's what it's going to be targeting. We're going to get into detail later. Now, let's keep going. Let's keep chipping away. Here we go. We're still in the lateral spinothalamic tract, right? Traveling up, traveling up. Of course, what happens now? This mofo branches again. What does he branch into? Spinocephalic fibers. Cross this one off. Spinocephalic. Okay, why in God's name does he do that? Well, we have something here in the middle of the body, in the brain area, brainstem, known as the cerebral aqueduct. We've spoke about him a lot. What was he used for? Well, this is the area where the third ventricle passes through, what? Towards the fourth ventricle. Okay, so this is the area where the third ventricle kind of is. Don't need to get into that now, but that's where the cerebral spinal fluid was built or accumulated from. Whatever. Okay, so spinocephalic fibers target something that surrounds the cerebral aqueduct. So the cerebral aqueduct is very important, but we got to cover it, right? We have to cover them up, protect them a little bit. This is known as the periaqueductal gray matter. Okay, this periaqueductal gray matter, we're going to talk about it later on, but this periaqueductal gray matter is going to shoot up to different fibers, and what are these fibers traveling through? Well, this was our spinomesocephalic tract. Okay, chipping away. One more time, baby. Lateral spinothalamic tract, right? Fibers continue running up. Where are they going now? Well, we know we got another branch. Branches off one more time. And this is going to be known as the spinohypothalamic fibers. Let's cross these buddies off. Where are they? Right there. Boom. All these tracks are covered now. We're chilling. What are these spinohypothalamic fibers? Where do you think they go? These boys are going to the hypothalamus. They're going to branch off into the spinohypothalamic tract. What happens when these spinohypothalamic fibers hit the hypothalamus? You guys know what it's called. Third order neuron, sorry. Third order neuron, boom. Travels up, does its function. We're going to have a video on hypothalamus, don't worry. Now, we covered all the different tracts. You're like, Joe, you're forgetting something. Yes, the ventral spinothalamic tract, right? What was he, the most medial one? Where is he going? Well, he travels up, and boom, he hits the thalamus region. Okay, and in the thalamus we have a couple different nuclei. We have the ventral posterior lateral nucleus, and we have the ventral posterior inferior nucleus. That's where this ventral spinothalamic tract is targeting. When it targets that thing, it's going to go into a bunch of different functions and orders, which we're going to continue to speak about. But just for now, I just want you to know the ventral spinothalamic tract ends over here. Okay, that's where his third order neuron is going to be, right? We know the third order neuron does what? It's the last one in our spinal tract section. Now, why do I have this? Parafasciculus and central median nucleus. Okay, So we said the lateral spinothalamic tract, right, has the A delta and the C fibers running up together, but mainly the C fibers were branching off to other regions. Why? What about the brown ones, the A delta ones? Well, he's going to branch off too. Like, he's going to branch off to the reticular formation. He might do a little branches here and there, but mainly, he's going to the parafasciculus and he's going to the central median nucleus. Right? When he does that, what does this do? Okay. I'm completely, no. Okay, so we talked about the lateral spinothalamic tract, right? It has one other function, or probably a couple others, but we're going to talk about one other thing. The green one comes up, right? The C fibers and the A delta fibers. The green fibers, not only do they stimulate all these other things, they also stimulate in the thalamus, or innervate, right? They target a couple different things. They're going to target the parafasciculus and the central median nucleus. Why? Well, these ones are for the emotions of pain. What the hell? Okay, what does that mean? You get hurt, right? You're like, ow. You start crying a little bit, right? Like, it hurts. Okay, so that's going to be over here. And what's it going to be? It's going to be at the anterior insular cortex or the cingulate gyrus. I'm going to talk about that later. It's way too much right now. Just know that these C fibers also help with our pain emotions. Like, I don't know, crying, like hurting, like it hurts sometimes. Now, the brown ones, right, the A delta ones, where are they going to go? Okay, unfortunately, they target into two different regions as well, and they go to the S1 and the S2 cortex. What are these going to do? We're going to talk about them, don't worry. Just know they're coming back up into the thalamus. Okay, so that's basically everything. Now, one last thing I want to mention. We know all of these tracts, right? They come from the, it could be right or left, we know. But say we're coming from the right side of the body. We cross over contralateral and we ascend on the contralateral side. Except for one guy. Of course, one guy who has to screw this whole thing up. Which one is he? So, spinal reticular tract, right? We said the reticular tract was mainly for the conscious pain. Well, if it's laggy pain, right? Constant pain, like, he's like, yo, buddy, I don't have to shoot over every single time. Like, dude, we already get it. I get it. I know I'm annoying, but I don't have to waste my energy shooting over. This is how I'm thinking of it. Maybe that's how he thinks. I don't know. Instead of him shooting over, he's like, screw it. I'm just going right to reticular formation, and I'm going to be the spinal reticular fibers, and I'm going to go up, and I'm going to be known as the spinal reticular tract. This is from the C fibers, as we know, and the C fibers are just going to the reticular formation on the ipsilateral side. Not most of the time, but some of the time. Yes, we know, for the most part, this tract, or this system, crosses over contralaterally. Just keep in mind that sometimes if there's a random crazy test question that was like, oh, do all anterolateral systems work contralaterally? No. Which one doesn't? Some of the time, the spinal reticular fibers go up ipsilaterally to the reticular formation, forming this spinal reticular tract. Okay, that was a lot in that video. Of course, missed one thing. Let me go over real quick. Remember we said the superior colliculus, right? He goes to the muscles of the eye. Where does the parabrachial nucleus go? Well, if you see over here, I have the body symmetrical, right? We have one on the left, we have one on the right. So say this orange one was on this side. So we have the C fibers coming from the, say we have the C fibers coming from the right side, contralaterally. They start coming up, right? They start coming up, they start coming up, they start coming up. They branch off right here into the parabrachial nucleus. Same thing on either side, I'm just drawing it from this. I'm drawing from the left side going to the right side. Branches off into the parabrachial nucleus. He travels up and he's going to target the amygdala. The amygdala is going to be our fear, like our pain, or like just one of our lobes. We're going to talk about more of the amygdala. I just know of him, remember him for like fear. Okay, well, that's basically everything we need to talk about. Yeah. So, if you have any questions, just let me know, and I hope it helped. Okay, so we'll do 2 quick questions, and then we'll keep going on the video. Patient shows deficit in proprioception and 2-point discrimination on the left arm and the rest of the left side of the body below the arm. Oh, that was a lot. So let's just underline real quick. Proprioception, 2-point discrimination on the left arm, and the rest of the left side of the body below the arm. Left side of the body below the arm. Okay. No other sensory deficits are found on either side. Okay, so no other sensory, so that's fine. And no motor deficits are found. Okay, so we know it's something with an ascending fiber if there's no motor. So we know it's something with ascending. The sensory deficit is consistent to damage with which of the following tracts? Okay, so we have a couple tracks here. So let's just go through our normal thing. You know how we answer all these questions. Okay, so now we see, proprioception. So what I proprioception. And we're going to say 2-point touch. Okay, so now if you have this memorized already, you should know what the answer is. But if you don't, we could keep breaking it down and we could get it a different way. All right, so 2-point discrimination on the left arm and the rest of the left side of the body below the arm. So it's going to be on the left side of body. So left side of body. And where else? Left arm. Okay, so something has got to be ringing a bell for you guys now. So what would you do here? Well, we could draw our structure, and we know they always come in through the posterior gray horn, and now they could go a couple different ways. Well, let's see. We could go like this, and we could shoot up, or we could go from here, and we could shoot up, or lastly, we could come through the ventral gray horn. But what did they give us? Did they give us anything about the ventral gray horn? No. Oh, the ventral white column? No, they only gave us information about what? So they gave us fasciculus, gracilis, and cutaneous. Okay, so that we know that's in the ventral or in the dorsal column. They gave us lateral corticospinal tract. Okay, maybe, but definitely not because it's corticospinal. We're not talking about motor. And they gave us anterolateral. So anterolateral is from where? Well, it's from the lateral sides. So nothing about the bottom here. Okay, so I'm going to erase that just so it doesn't look crazy. Well, even though that ruined what I wanted to do, but what could I tell you? Okay, so now what do? We keep going through the system, or we keep going through our process of breaking things down, and what do we see? Left arm, left side of the body. So if it's coming from where? This would be the right side, right? So we could redraw our picture. And let's redraw the structure and have it come from the left side, or the left, let's have it come from the left side. Because we're looking at the patient, we're not looking at ourselves. If we're looking at ourselves or looking at the screen this way, this would be the left side, obviously. But we're looking at someone else. So if it's coming from the left side, and it's staying on the left side, so what does that mean? Well, it can't really cross over because this would go to the right side. So it's got to come up through this way. All right, so if it comes up through this way, where is it passing through? It's passing through the dorsal white column. Okay. If it's passing through the dorsal white column, I know I threw this curveball at us, but I just wanted to reiterate the fact that we can't just assume and guess through these questions, like when I give them in the YouTube videos. So we just spoke about anterolateral. However, we know this is not the answer. Why is this not the answer? Well, anterolateral does what? It does contralateral. And if anterolateral is contralateral, it would not talk about the left arm and left side of the body. What stays on the same side? What is ipsilateral? Well, ipsilateral is for the dorsal white column. So now we have to distinguish if it's the left or the right side. And how are we going to distinguish this? Well, we know it's ipsilateral, so what does that mean? It's on the same side, and if it's coming from the left side of the body or the left arm, what's the answer going to be? Left fasciculus, gracilis, or cutaneous on the left side. What was gracilis used for? This is for the lower half, T6 and below. And what was cutaneous used for? The upper half, T5 and above. Okay, so B is going to be our answer. Here we go. Fasciculus gracilis and cutaneous on the left side. Now, I'm sorry that was annoying, but just wanted to reiterate the fact. Now, another one. A patient shows a deficit in pinprick. Actually, hold on. Okay, what else could we mention here? Say we didn't really go through the whole process of knowing ipsilateral and contralateral. What if we went through just the process and we just read the first question and we saw deficit in proprioception and 2-point discrimination? Our eyes should light up. We should be like, oh, proprioception. So important for what? It was so important for our 3D space with our eyes closed. Okay, and then I was like, where is this going? Well, this is going right through the dorsal white column. We said this in the previous video. What about 2-point touch? Well, 2-point touch was the 2-finger things, right? If 2 fingers just deviating between 1 finger on your hand or 2 fingers on your hand, etc. If we were talking about, right, the anterolateral system, what would this be? Well, this would ask us for, in the question statement, it would say crude touch. What else? It would say pain and temperature, right? That was for the anterolateral system. So if you knew that the question said proprioception and 2-point discrimination, you could automatically cross out anterolateral on the right side and the left side because it's talking about what? Proprioception, so that's not in this category. You could also cross out lateral corticospinal tract because why? That's for motor, not for sensory. Then all you would have to do is figure out if it was left or right side. But whatever way you figure it out and you got the question right, go for it. Now, one more. A patient shows a deficit in pinprick sensation. Okay, we just covered that. Pinprick sensation. Testing on the left arm and the rest of the left side of the body below the arm. No other sensory deficits are found on either side. Okay, so there's nothing wrong on either side of the body. After this pinprick location, no motor deficits are found, so we can cross this out. We know there's no motor deficits. The sensory deficit is consistent with damage to which of the following tracts? Let's go through the answers real quick, or the choices real quick. Okay, next question. A patient shows a deficit in pinprick sensation testing on the left arm and the rest of the left side of the body below the arm. Okay, so, what are we talking about? The left arm and the rest of the left side of the body below it. Okay. We kind of just talked about a question like that, but let's keep going. No other sensory deficits are found on either side. No motor deficits are found as well. This sensory deficit is consistent to damage to which of the following tracts? Alright, so if there's no other sensory deficits found on either side, we need to know it's staying consistent. And if it also says there's no motor deficits, we know it's no descending. It's only an ascending fiber. Okay, so if it's no descending, which ones are descending? Well, if we look at our answer choices, we see lateral corticospinal tract, so we could already cross them out. Now, if we have our different sensations, right, say pinprick memorized, we could know what the answer is. However, if we don't know what that is, or if we don't have it memorized and we want to go through it, we can. Here we go. Oh, that's a bad circle, sorry. Okay, so if we have this guy, right? Here's our little thing. Okay, so it's coming from the left side of the arm, or it's the left arm, comes in, and it's on the left side below the arm. Okay, now, what does this mean? Well, it could go straight up, right? And it could be T5 and above, which would make sense for it to be the fasciculus cutaneous. Okay, but what if it comes from the arm and it's below the arm as well? Okay, could it be the fasciculus gracilis? Well, not really, because these guys are separate from each other. What could it be then? Well, what if we cross over? Why would I cross over? Okay, let me draw it again. I drew a couple of them. You guys probably know why. What did we talk about in the last video? The tract of Lissauer. So what is that tract of Lissauer? So say the pain comes in, right? Pain comes through this horn, right? And okay, we're going left arm and below. So instead of just shooting right across, which he does, and comes up, he also goes down, and he also comes up on the ipsilateral side, about 2 or 3 vertebrae. Now, if he does that, and he stays in this side, he eventually is going to cross over into the lateral Y column. When he does that, he's going to shoot up and send the sensory information back to the brain. Okay, so if it says the left side of the body below the arm, okay, that's what we have. We have the left arm and the rest of the left side of the body below it. So we know it's going to be in the anterolateral system. So these two guys are out. Now, is it going to be the left side or the right side? How are you going to distinguish between this one? Well, where does the sensory information come from when you're talking about the anterolateral system? It comes from the contralateral side. So if the pain is in the left side of or the left arm, right? That's a weird L. Apologies. If it's in the left side of the body or the left arm, the sensory information is coming from where? Well, it's coming from the right side. It's contralateral. So this would be left, crosses over to the right side. So boom, that's going to be our answer. It's going to be the anterolateral spinothalamic tract. Let's see if we're right. Yes, we are. Anterolateral spinothalamic tract on the right side. Remember, the ALS, anterolateral system, crosses at the segmental level, while the DCML system crosses at the base of the brainstem. What is the DCML system? This is for the fasciculus gracilis and the fasciculus cutaneus thing. That crossover is at the brainstem. I had this in a different video, but you can go into more detail there. That's in the anterior or the ventrolateral system. This stands for the dorsal what? Dorsal column or dorsal column of white matter. Let me write it out for you guys. Dorsal white column of, what does ML stand for? Medial lemniscus system. I know it's a lot, but whatever. Okay, that occurs in the brainstem. Now, in an ideal world, where we have an amazing memory on test day, which is really hard to have. I don't have that ever. That's why I have to break it down like this. But if you do, and you see pinprick, you should be like, okay, pinprick, what is pinprick? Pinprick, is that 2-point touch? No. What was that? Just one type of touch, right? Like a little pin touching you or someone's hand touching you. And we said that was what? Crude touch. Okay, so crude touch goes with what? Crude touch was also with pain and temperature. And they used what? Merkel cells. And they used nociceptors, remember? And all this stuff occurs where? This anterolateral system or the spinothalamic tract. So if you just see pinprick and you're like, boom, anterolateral tract, you could cross out all of these 3 choices. And then you say, if you know it's that system, but if you see it occurs on the left side, you have to be like, no. It's going to be the right tract. If it occurs on the right side, no, left tract. Other than that, you guys should be good. Okay, so let's get going. The system we said is the anterolateral system or the spinothalamic tract. Right, okay. What does this mean? Well, we're located where? This is our nucleus, right? Our little guy, there it is. We've talked about him hundreds of times. Got the dorsal, got the ventral, and then you have the lateral, right? On opposite sides. The white matter on opposite sides. Remember, our bodies are symmetrical. I know a lot of diagrams show this thing split in half and they show the ascending on one side and descending on the other side. Don't look at that. It's like, I guess it's correct, but the real structure, we have symmetry, so it's on either side. It's not one side ascending, one side descending. No, it's on both sides of this system. Okay, so here we go. We said we're gonna do two main tracks first, and then I'll talk briefly about the other, like the small ones, but let's start off with the big ones first. So you have the ventral anterior tract. He's gonna do crude touch and pressure. Okay, what is crude touch? Well, it's like your whole hands touching your body, like You hit a wall, your arm touches it. You're not worried. Crude touch is just like big touch, really. Pinpoint or 2-point touch is like 2 different fingers, right? This is 2-point touch. Pin touch, however, could be associated with crude touch, because like you just get a little pin stuck to you, okay? You feel that pin. You don't feel 2 different areas. That's what we're talking about when we talk about crude touch, okay? And then obviously pressure, we know what pressure is, just applying pressure or force to you. Okay, so those 2 senses are going to come from the ventral anterior tract. Now, the lateral tract is going to occur, or is going to carry pain, temperature, and sensations. Okay, what does this mean? Well, we know what pain is. We know if you touch a hot stove, it's going to hurt, and the stove is going to be hot, so we're going to feel the pain and the temperature. And it's obviously a sensation. Like, what is a sensation? You touch something, you could feel what it is. So I think the perfect example for this one is touching a hot stove. You feel both pain, you feel both temperature, and you're like moving your hand away. Okay, so now I have the type. Well, we're talking about sensory. Why? Because we're only talking about ascending tracts right now. We're not talking about the descending tract. Okay, and then like I said, it's the anterolateral system. See all these different tracts I have written? We're going to go over them, but the 2 ones with the stars are the main ones. It's the lateral spinothalamic tract. That's literally the lateral tract. That's what it's called. Lateral spinothalamic is its full name. And then anterior spinothalamic tract. That's this ventral or anterior tract. It's the same thing. You know, ventral and anterior means the same. It's similar to posterior and dorsal. Okay, so these are the 2 main guys. Now, the ones underneath it, not as important, but we're going to still talk about it. It's the spinotectal tract. It's the spino-mesocephalic tract. We have the spino-hypothalamic tract. And then you have the spino-reticular tract. Okay. But before, let's talk about, I know this diagram looks crazy and all out of whack, but it makes a lot of sense. Just bear with me here. Remember in the last video, I don't know if you watched it or not, but the last video we talked about the dorsal column with the fasciculus gracilis and the fasciculus cutaneus tracts. Okay, we used certain fibers. What fibers were involved in that tract? We had alpha or AA fibers, we had AB fibers, and AD fibers. Okay, what fibers are we going to use in this tract? Well, we're still going to use our alpha or our A fibers, but now we're also going to add something else. We're going to add C fibers. Now, I have it written right here. Remember, we have A, B, and C. A was what? The most myelinated. It's the fastest fiber. C is the least myelinated. It was the slowest one. And B was in between. But for this right here, we're not talking about B. We're just talking about A and C. Particularly speaking for this tract, we're talking mainly about alpha or A delta fibers. So I have it right here, A delta. What was he for? If you remember, he was prick pain or the slowest. Remember? We said if you got pricked or you got touched, that pain is coming from the A delta fibers. Okay, now, you see how I have all different colors and like all different drawings and things going up and down? Yeah, frustrating, I know. But we're going to talk about it. The first one I have here, I have nocioceptors. What are nocioceptors? Well, if you look at the skin video we made a while ago, nocioceptors respond to pain and temperature. Okay, so I have written pain and temp. Okay, these receptors are stimulated where they target 2 different types of fibers. Alright, so now in order for them to get processed or something, they go through an alpha delta fiber or a C fiber. What were C fibers? We didn't really talk about them, but I'll talk about it right now. The C fibers, they're used for dull pain. Okay, what is dull pain? Well, naggy pain, like chronic, like, okay, you get hit in the arm, right? You get a bruise. And now, 3 days later, you still feel that little like achy, dull pain. It's not really like severe. Like, it's not like getting pricked with a pin and you're like, ow. It's like, no, it's just long, draggy pain. That's going to come from our C fibers. Okay. So, the alpha delta C fibers are going with the nocioceptors. Now, we covered what? We covered pain. We covered temperature. What else do we need to cover? Well, we covered crude touch, kind of, with the dull pain, kind of. We still need to cover pressure and different types of sensations. Okay, what is going to stimulate those? Okay, we have if you remember from last video, we have Merkel's discs, which were light touch. We have peritracheal free nerve endings, which were those. Those were the ones that were like attached to the hair follicles, and they stimulated the sensation of the hairs moving up and down. It's also, if you pull your hair, it kind of hurts a little bit. Well, that's going to be these nerves. What else? Free nerve endings, that's just all over like different regions of the body. And what are these three main things doing? Specifically the Merkel's discs and the peritracheal. What do they respond to? Well, we said Merkel's disc was light touch, so they're going to respond to crude touch, and they're also going to respond to pressure. Okay? So if they're responding to crude touch and they're responding to pressure, what fibers do you think are going to be used here? Both alpha delta or A delta and C fibers. Same thing. Now, you would think, like, I don't know who created this system, but you would think that all of these fibers would mesh together because they're the same exact things and go up through the body. Unfortunately, doesn't happen. I don't know why. But we'll talk about what actually occurs in, like, right now. Okay, so the A delta ones, right? A delta travels down, and when, say you get like this little like temperature, the thermal touch, right? Thermal sensation. Well, something's got to stimulate him. Where is this, or like who sends the fibers where? Okay, the dorsal root ganglia, we spoke about that a lot. This is where the fibers diverge or converge, right? They come together. So the nociceptor, right? Nociceptor feels the pain. That pain goes all the way down, right? Say right over here, right? Nociceptor touches it, and what happens? That fiber starts rushing down into this region. When that fiber from the nociceptor joins to this alpha delta fiber, this is called our what? Our first order neuron. First order neuron is where? Well, it's going to be in the dorsal root ganglion. It's going to be in a root. It's going to be one of the roots. If you remember what roots were, they came all the way out, like I drew it from here in a previous video. I'm pretty sure I explained it the best in the intro to the spinal tract video. But just so you guys know, the roots come out, and this is where the first the first dorsal ganglion is where the first order thing occurs. Okay, so we have our first order one. Now, that's going to be the same thing for the C fibers and the alpha C or alpha delta C fiber. Okay, whatever. I know that was a lot at one time, but just bear with me here. We're sticking with this guy first. We're sticking with the brown one, the alpha or the A delta fiber. Okay, so the temperature and thermal sensation, right? First order neuron starts. He's traveling down through the dorsal nerve root. He travels into the, where? Posterior gray horn. Remember posterior and anterior? This whole area was the white matter. This middle part is the gray matter. Okay, let me draw this little circle in here too. Okay, now, dorsal, lateral, ventral, right? Dorsal for posterior, ventral for anterior, lateral for lateral. What happens? Well, if we remember in the dorsal video, the dorsal white column, these fibers came in through the posterior gray horn, went into the dorsal column, and shot up. Unfortunately, different tract. Okay, so we're still sticking with our A delta fiber. He's going to come down. He's going to be in the ventral gray horn. What happens? He's going to be in the posterior gray horn. Now, he shoots across. Wait, whoa. Why does he shoot across? Well, he's going to target, right, another neuron right here. Pseudo-unipolar neuron, it's called. Pseudo-unipolar. What is this neuron? Well, this is where this location is going to be our second order neuron. Remember we have three orders, always, mostly for these tracks, first, second, and third. Well, the first one was up here. The second one is going to be right over here. What is this going to be called? Or where is this going to be called? It's going to be located at the the gelatinosa of Rolando. Can't really pronounce that. But it's the substantia gelatinosa of Rolando. That's where the second order neuron is going to occur. Okay, you see underneath that I have the Lissauer's tract. Why? I'll explain. So all these three tracts, right? I'll go over C and I'll go over the green one and the pink one after, but let me go over the brown one first. So these three tracts, or these three roots, the fibers, they travel down. And now most of the time, or all of the time, they're going to shoot across. What happens when they shoot across? This means it's contralateral. So it's going to the opposite side. So if it's on the right side of my body, boom, we're going to the left side of this root. So if we come down to the left side, we're going to pass something called the anterior white commissioner. What is that? Okay. This region down here, remember we said it was the anterior or the ventral white matter, white column? Well, this fiber is going through the ventral white fiber, known as the anterior white commissure, and then he shoots up across, and where is he now? He's in the lateral white column. Of which side? The opposite side. Okay, we started on the right side. Came through the right, where? Right posterior great horn. Shot across. Crossed over this little circle. What is this circle called? It's called the central canal. Holds cerebral spinal fluid. Just, I don't know, something to know. Shoots across. Shoots across into the where? Left anterior gray horn. Goes through the left anterior great horn into the white, or the anterior white commissure. Shoots back up into where? The lateral white column. Now, didn't I say that we had different tracts? Yes. This brown one, right? The one for nociceptor, the A delta. What tract is he? Well, he's going up through the lateral spinothalamic tract. Huh. Why is it lateral spinothalamic? Well, if you look at these three fibers, 1, 2, and 3, right? Pink, green, and brown. Well, he's the most lateral one. So if he's the most lateral one, most lateral tract, it would make sense for him to be called the lateral spinothalamic tract. And where was he? He was one of the main guys we spoke about. Remember, we have two main guys, ventral anterior and then lateral tract. I should have wrote ventral anterior spinothalamic. Let me write it, spinothalamic. And then what is this one called? The lateral spinothalamic tract. Okay, so those are the two main ones. So here's the first main one we're starting to cover. Now, what did I just say? The second motor neuron does what? Well, it happens at the substantia gelatinosa of Rolando. What is that called? Or what happens here? Well, we have something called the Lissauer tract. Oh my God, of course, another thing. Right over here, I'm going to show you guys the Lissauer tract, or the tract of Lissauer. It looks like crap, I know. Say we're at T6, right? We have the T6 vertebrae. What's above him? Well, obviously T5. What would be below? What would be above T5? Well, T4, right? What's under T4? T5. What's under T5? T6. What's under T6? T7. What's under T7? T8. Random example. I could have done it anywhere. Now, say we're at T6, right? We have pain around the T6. Pain comes in. Now, before we talk about what happens, I want to mention, if we remember what the brown one does, right? The alpha delta, or the A delta, was for the ventral spinothalamic tract, received the information from the right side. It went from the right side down to the left, okay? Same exact thing. It's going to start off on the right side. It's going to travel down, across, right? It's going to go into the anterior white commissure, and it's going to shoot up through where? The lateral white column. Good. But if you look, you're going to say, why the hell do you have all these pink things connecting? Okay, so that's the tract of Lissauer. What does he mean? So when the pain comes in through T6, he could go up to T5, even up to T4 potentially, or he could come through from T6 down to T7. He comes down to T8. He could even go down to T9. So when you have pain or a lesion in one of these tracts, specifically speaking, the lateral white one, or the lateral white column being the ventral spinothalamic tract or the lateral spinothalamic tract, a lesion here is going to cause what? It's not going to cause direct pain on T6. Say the lesion is at T6. It's going to really cause pain down below at like T7 or T8. Because before it crosses over, it's also coming down and then crossing over. This one here, it's crossing over right over here, But where do you think T6 is getting most of his info from? You think it's directly from T6? Well, it's probably from T4, coming down, and then shooting across. That's how the body was designed. It's worked contralaterally. I don't know. So it comes down, goes across, and then what happens? When it goes across, then it shoots back up on the opposite side. That's why it's known as contralateral. Okay. I know there's a lot for this little thing, but it's a good thing to remember. Now, before I go off topic again, let me hop back on. What do we do? So, this brown one, what did we say he was? He was used for what? The lateral spinothalamic tract. And he was for temperature and thermal sensation. Now, you see I have the green and the pink one. Let's go with the green. Green is for the slow and dull pain. But you're like, Joe, he's branched off a nociceptor. Exactly. That's why it makes a lot of sense. The green one comes down, does his second order neuron right at this region, shoots across, goes into the anterior white fissure or commissure, shoots up. When he shoots up, he's a little bit more medial than the lateral spinothalamic tract itself, but he's a little more lateral than what? The ventral spinothalamic tract. Why? Well, these two tracts, these two fibers, when they come together, they're known as the lateral spinothalamic tract. Oh boy, what the hell? So it makes sense when you see the nociceptors, right? Is for pain and temperature, split two different ways. If it's the temperature and thermal sensation through the A delta fibers, or it's for slow dull pain through the C fibers, they're still going up the lateral spinothalamic tract. They just use different fibers to start off, right? To start off the process. And why would they use different fibers? Based on the speed. If you're touching a hot stove, you want to be quick, right? Like fast. That's why it's going to be most myelinated. If you're touching like an oven that's like barely heating up and it's slowly going slow, you're going to be like, oh, whoa, okay. It's like a dull pain, right? But it's for nociceptors. Just remember, both of these guys come together and they form the lateral spinothalamic tract. Okay. Last one so far. We have Merkel's disc. The peritracheal free nerve endings, right? They were used for the crude touch and pressure. Why? Well, I don't know. That's what they're used for. And what fibers do they use? Well, they use A delta and they use C fibers. However, luckily, they're not really split out or like branched out like the nociceptor was. So now these two fibers come together, or not come together, they are together, right? Joined to where? Their second motor neuron, or second order neuron. Where was the first order neuron? Right up here. Whatever that pain or stimulus was the first order neuron. Where was it? The dorsal root ganglion. Good. Comes down. Second order neuron. Where was he? Same exact thing. Substantia gelatinosa of Rolanda. What can he do? Well, he could go up or down via what tract? The Lasauer's tract. If he shoots directly across, like I have, shoots directly across, crosses over where? Around the central canal. Goes into the left anterior great horn. From the left anterior great horn, he goes into the anterior white commissure. From the anterior white commissure, what does he do? Shoots up into the left lateral white column. He started from the right side, crossed over, contralateral. Now we're traveling up through where? The lateral white column on the left side, but what tract? He's most medial, and he also goes most anterior, or most ventral. He's known as the ventral spinothalamic tract, right here. So now, we have two different tracts traveling up. We have the lateral spinothalamic tract shooting up, and we have the ventral spinothalamic tract shooting up. When these guys shoot up, they can do different types of functions. We're going to talk about them. Okay, so let's take it home here. A 50-year-old man is brought to the emergency department with severe back pain from a motor vehicle collision. Okay, examination of the right lower limb reveals weakness. Okay, so right lower limb, we have weakness, hyperflexia, positive Rybczynski sign, loss of tactile, vibratory, proprioceptive senses. Oh my God. And the left lower extremity has a loss of pain and temperature. Okay, so we have pain and temperature sensation from the toes to the left iliac crest with intact motor function. Okay, at least he has intact motor function. So before we keep going, let's go to all our answer choices and cross out the motor function ones. So we know the dorsal, the corticospinal tract. What else? We could keep going. We could say another corticospinal tract. See you later. We could say the right dorsal columns, left dorsal columns. Maybe. We'll just hold on to them. For the most, what else do we have? For the most part, I think that's all of the motor ones. I don't know why that one crossed out like that. Okay, so now, there is so much here. What does the question even ask? Transection of which fiber tract resulted in the left lower extremity sensory abnormalities? Okay, so they gave us an explanation of the right lower limb and the left lower limb. So everything that we've just read about the right lower limb revealed what? Weakness of hyperflexia, positive sign, Babinski, tactile, vibratory, proprioceptive. We saw proprioceptive and we were probably like, that's probably going to be what? We said it was the ventral. The posterior, right? Let's draw that real quick. The white column. Damn it. So it was probably the dorsal white column is proprioception. Luckily, that was not being asked, so we could cross him out. Vibratory, he was in both lateral and dorsal. Loss of tactile, I don't know what that even is. Babinski sign, oh, okay, so this is a reflex, so this is motor. Hyperflexia, motor. So we could cross this whole guy out. Thankfully, it's all about motor, so we don't have to worry about any of that. Now, what else is it asking us in the left lower extremity? What the question's asking us? Well, the question asked us about what? Left lower extremity is a loss of pain and temperature. Fire. Well, it's not fire for the guy, but for us. So which fiber resulted in the left lower extremity sensory abnormalities? So if we were able to remember pain and temperature was for which type of tract? If you don't remember, it's fine. Let's just keep going, chipping away. Left dorsal columns. No, this is not a tract. This just goes through things. Left dorsal spinal cerebellar. Maybe. Left spinothalamic. Maybe. What else? Right dorsal columns. Nope, this is not a tract. Right dorsal spinal cerebellar. Maybe. Right spinothalamic. Maybe. Okay, so now, if we take this guy out, erase him real quick, and then we start drawing our own guy. We draw him, we draw that, draw the circle, right? And it says lower extremity sensory abnormalities. So we know it's got to be some ascending fiber. It also says from the toes to the iliac crest, so it's not really shooting up all the way up our body. So what if it's only shooting up in one area, and it's on the left side, we know we're talking about something that's coming through where? Well, it's got to come through the horn, posterior gray horn, and now it could go three different ways. It could go up through the ventral, or up through the dorsal, up through the lateral, or it could go up through the ventral. Now, the answer choices, right, they only gave us the dorsal spinocerebellar, which is where? Down here. So, okay. Spinothalamic, which was lateral. Spinothalamic again, and dorsal cerebellar. So we know it can't be the dorsal root column. It can only be in the lateral or the anterior. Now, what was pain and temperature used for? Well, if you remember what pain and temp was used for, we know the answer is going to be what? Spinothalamic. So if it's the spinothalamic, right, how are we going to differentiate between left and right? So we know it can't be cerebellar. We said it was spinothalamic. Now, if it's on the left side of the body, right, what does this mean? Well, what does this tract even do? This tract is contralateral. Okay, so this is the left side of the patient's body. This is the right side. It's coming from the left side, crosses over, and ascends upwards. But the left side of the body was the injured side. That means the nerves, or the fibers, or the tract comes from the right side. So we got to have the right spinothalamic tract. That's going to be our answer. Let's see if we're right. I don't even have it down, but yeah, that is the answer.